Hi, welcome to Wise Guys. Multiplication of radicals. Multiplication with radicals. Let's see the first question. Square root 6 multiply square root 2. Sometimes we don't need to write the dot. Just write the square root 6, square root 2. But this is, I want to show this is multiplication, right? So follow the rule, we can, because radical, square root, they have same radical, we can write together. And also, we don't need to multiply got the 12, but we need to separate and to factor. 6 can be write into 3 times 2, right? And this is another 2. So we got a pair of 2, which is square root. So in this situation we got 2 get out radical 2 root 3, right? So root 2 multiply root 2 equal 2 root 3. Second question. If you have cube root 9 multiply cube root 6. The same thing we write together. Write the cube root, because both cube root, we share one cube root, we write the 9 with 6. Then we factor out 9 and 6. 9 equals 3 times 3. 6 equals 3 times 2. Then we see we got the 3, which is can get our cube root. So the answer will be equals 3 cube root 2. That means when we working with multiplication of radical with same radical index, we can share this at the same radical, then factor each number if we need, right? And then we look at how many pair for square root, how many triple of number for cube root. The next question say that means if you have square root, you need to find 2 of them. If you have cube root, you find 3 of them. If you have this situation, 4th root 8 times 4th root 2. So same radical index, we share the same radical index as 8 times 2. And then we can factor out 8. 8 we know is 2 times 2 times 2, and then times this 2, so we get 4. If you write this one, it's 2 to the 4 exponent, which you cancel with the index 4, if the answer is 2. Next question. Say if you have a radical multiply a binomial 21 square root 14, with this kind of question. This is follow exactly multiply monomial with binomial. So we do distribution and this, right? So we got square root 7 times square root 21, same square root we share, and the same radical, which is 7 times 21. Then we say this is 7, this is 21. How are they related? 21 equals 7 times 3, 3 times 7. That's why I write 21 into 7 and with 3, right? See? This one. These two. Actually this one, right? This one. And share the same radical, then we can see we have pair of 7. So next step, for the next step, we can get rid of 7 out of radical You got 7 root 3, right, for this one. And we multiply, okay, let's say multiply the next, be careful with the sign. This is negative, this is positive. You got the negative. This one, so share the same radical, 7 and 14, we can write into 7 multiply 2, right? See, these two, let's come here, right? But then we can write this one minus, you have pair of 7, get out, write the square root, you got square root 2. For this situation, you see 7 radical 3, 7 square root 3 minus 7 square root 2. We cannot do it. The reason is square root 3, square root 2 is not a similar radical. But for this one, we can pull out the coefficient, the 7, as common fact. We can write it this way. 7 bracket square root 3 minus square root 2. Right? Better have answer this way. So pull 7 as common fact. The root 3 minus root 2 stay inside the bracket. This is a question 4. And question 5. Let's see, some situation, if we have binomial multiply binomial, what happens? If both are binomial and with radicals, we still can simplify them. For example, you have, let's say, square root 2 plus square root 3 multiply, let's say, square root 2 plus maybe square root 6. The binomial multiply binomial, we follow the distribution Fourier rule. So these two multiply together first, right? So we got square root 2 multiply square, we can write together square root 2 times square root 2. This will be equal to. And then go, this will multiply that one, which is plus square root 2 times square root 6. So this one, how to simplify this one? Because this one, you got square root 2, 6 is 2 times 3, right? So eventually you will got a pair of 2, get rid of radical is 2 root 3 for the second. And then we already did this one when working with root 3. So root 3 multiply root 2 multiply these two. We got root 3 times root 2. This is multiplied together because root 3 root 2, you got the root 6 and nothing you can simplify. So carry down this one. The last one, root 3 multiply root 6. We got root 3 times root 6. Then we can simplify this one, root 3. Root 6, we can factor out 3 times 2, right? Then we have 3, a pair of 3, get out the radical is 3 root 2. Right? 3 root 2. That situation, you can see this question after you combine, say this is 2 is a whole number, 2 root 3 is radical is root 3, radical 6, radical 2. All different. Different without radical here. Radical 3, radical 6, radical 2. Nothing you can combine. All different. That's the answer. This is the answer. If you want to write nicely, you can write, start from this one, 2 plus this small one, 3 root 2 plus 2 root 3 per root 6. But actually, this one is not very necessary, but it looks like nice. Okay? Next question, I want to show you more useful and important. Let's see this one. So if you have, this is a question 6. If you have root 2 plus root 3 squared. How to do this? So we can write this one into 2 brackets, root 2 per root 3 times another root 2 per root 3. Do the same job, distribution. 2 times 2, root 2 times root 2 equals 2, right? Because you got a radical, and you have, you can still write step by step. And this one, root 2 multiplied root 3, you got root 2 times root 3. And this one is root 3 multiplied root 2 is root 3 times root 2 plus root 3 times root 3, right? See, then you simplify. This is equal to 2. Get 2 times 3 is 6. This is also 3 times 2 is 6. Plus this is root 3 times root 3 is 3. And the answer will be, you got, this one is 2 plus 3 is 5. And root 6 is similar radical, which you combine. This is in front, the coefficient is 1, and 1 you got 2 root 6. This is the answer. Right? The last question I'd like to show you is this one. If you have root 2 plus root 3 multiply root 2 minus root 3, what happened this way? So they have same radical, root 2, root 2, root 3, root 3, but one is plus, one is minus. If you follow it exactly way, so you can see at this step, you will got one negative because this one multiplied this one is positive, right? I'll show you here. Root 2 times root 2 plus this one times this one, which is minus, should be minus. It's not plus, it's minus, minus root 2 times root 3 plus root 3 times root 2 minus root 3 times root 3. Then you can see, because one is plus, one is minus, when they do for you, so you got one is minus, one is plus, exactly same. You got the root 6, root 6. So these two exactly same, but opposite sign, we can cancel each other. So answer is this one got the 2, this one got the 3. The answer is -1. This is maybe you ask for, is any question if they have same radical but opposite sign, they all result as whole number, the radical will cancel out? Yes. So actually this one, you remind you this one in algebra formula. When you do factoring, remember this one is kind of square root, is kind of a plus b, a minus b, which is a squared minus b squared. This is follow this formula, right? So even you can do one step, you say, because of this formula, we can do square root 2 square. You can write this one, and square root 2 first number square minus second number squared, which is 2 minus 3, which you call -1, right? So yeah, so you can see the same answer. One is do step by step, do each of them. The other one just follow formula. Actually, after practicing, this is very useful. Okay. So this is the multiplication of radicals presented by wise guys. Thank you.